All right, so the Nist report comes out, well, part of it, and Nist is trolling. They're trolling. They're stating the obvious, and then they're trolling. They're using here's your chart, location of under strength. Let's just zoom in on this triangular array. Remember, this is 1, 2, 3, and this is 4, but this is offset by 6 feet. Triangular array, excuse me. Rectangular array, it doesn't meet rectangular array percentages. Nowhere do they talk about rectangular array in this report, but you get circles and arrows. Arrows represent, if you look at the arrows, two-faced, side, two-ended, slab flexural. They're using this one. This is the one with the image, slab flexural going north and south. Clearly, the end of the box shows it's separating, which they have part of their drawings. Here's the column here. This box is going this direction, rotating down. They're just showing north and south and west and east. So west and east, they're showing that the deck is moderate slab flexural. So this is a section here, they're saying moderate. They're just stating the obvious with what we know. These are columns that all have punching shear on them, right? All this had punching shear on it all the way through. They're stating the obvious. It's a troll document. It's enough to just like say really what it's not catfishing. What's the word? It's sea lining. It's a phrase you guys can look it up. It says the sea lining document. They leave off the fracture. It's over there. Inside this drawing here, they break it up with different crap. Over here is where I do the video that's coming out. Giving a shout out to Cheese Blogger, because Cheese Blogger deserves it. I gave the hint. I talked about axis. Sorry guys, I'm working on about 4 hours of sleep here. The axis points in there. I'm sorry for clarity. The neutral axis points, and I talk about here we go, about how the steel comes across over. Comes across over here. It's going up tomorrow. Maybe I should bring Cheese Blogger up already and let him get his credit. Cheese Blogger, just hold on for tomorrow, man. You're gonna get your credit. I'm gonna post this now though, and it'll have this in it. So they're showing that, so that it flap down. But I use the real images to not prove it, but to talk about the proof of concept. Using the real images we have. They're using, hey, trust us, we've got this drawing we made, right? Look at this. And like I draw on the screen. And, it's cool. All right, this is something they're calling negative, bad. They're saying that the 3/4 inch cover was as designed, but they went to 2-inch cover here. I tell you that works in your favor at the column area. And ultimately everywhere. Again, I want you to use the theory, the idea of, I want you to pick up a piece of steel. You can say it's this piece of steel, but this time do not use your thumb. So do not use your thumb. You're going to grab it, and when you grab it, here's that steel. You're not going to be able to use your thumb, so you're not going to be able to give any grip force underneath. So this would be the equivalent of the thinner layer of concrete having a weak thumb, a weak grip. The better the grip, and that's done through testing. Okay, that's a home run. There's rebar right there. All right. So if the rebar was not covered at the bottom, Let's see, look at your strain here. Let's go with this one. So as it's stressed, it goes just like this, like that. And if you have a little bit of cover at the bottom, that they call cover, you've got less grip force, because it's been determined that grip force, and here's a rebar. Let's do a rebar like that. If you were to pull out this direction, pulling in that direction, you would get this like this. All right, it pulls like that. And that creates this cone effect. These little cones, there they are. That creates these overlapping cones and stresses. Now this area here may act as one, and so it's a lot to try to pull out. If you just try to pull it out, think of the top side now. That this is the concrete. All right, this time I'm going to give it a little bottom. I'm going to skim it real close. I'm going to skim that and give it a lot of fill up top. So this pressure this is all acting like stirrup material. It confines the pressure around it. Confines the pressure. Oh, over here though we don't have much pressure, because it's only called, quote, cover. It's just cover to protect it from rotting and everything else. No, that spalling indicates that that's part of that pressure cone that's failing. Not just if you can't find rust as part of the issue, then part of that pressure cone that's failing, this blasting out, if you will, away from the steel pressure cone, is because it's not enough of this, not enough stirrup concrete, if you will. So what the studies show is that if this is your concrete and this is your rebar in the middle, the greater the PSI out here, the stronger the bond on the steel. So if you were to use sand and plaster to hold this in, it wouldn't be a great bond. But if you use 8,000 PSI over 6,000 PSI, the same for same, you'll get a stronger deck with the higher PSI. It acts like it locks in. The 8,000 locks in better. So this becomes a stirrup, if you will, around your steel, your rebar. And so as you can see, your stirrup would be small if it was only 3/4 inch. So NIST is saying this is a negative, when I'm telling you it's a positive. They're indicating it as a negative. I'm telling you it's a positive. I don't know how this was saw cut, right? I don't know how they beat on it or not, but I can tell you about I can reverse engineer the saw cut for you. All right, watch this. Look at it. You can pause the video if you can. All right, here we go. First plunge right there. There's the line. Moved up a little bit, plunged. Next plunge, plunge down. Multiple little plunges. Look at the lines. Moved up. Next plunge. Looks like the plunge, and maybe drive forward. And took the pressure off. And then there's your plunges, your lines there. I'm going to remove this and you look at it. So this was the not an experienced person who cut concrete did this. They were all over the place. In fact, they drifted their machine in, because you could see a shelf made there. That means they moved it, they plunged out, then plunged back in, and it creates a shelf. The first one was further out towards us. The second one appears to be inbound even more. Same thing with these. They're in and out, in and out, in and out. So the person that cut this was drifting a lot, in and out, up, down, over. That creates vibration, and vibration, it's a lot of water on this, so that's supposed to stop. Let's lower the vibration. The vibration can create cracks, but if I zoom in on this, I could probably determine that it was probably not created by that machine. They do come in, they're cutting the steel there. They cut the steel and they didn't after they finished cutting the steel, it would have been bright bright looking. They let this steel age from sitting out, and now we get a rusted look. Let me tell you, that would have been a some brighty steel. This is the one that's worth zooming in on. It looks like it might be a little bit of separation right there. That looks tight. This one looks a little bit loose. This one's tight. Okay, if you could zoom in on it, the top of it. It reminds me of that core sample with that little tag, this thing. Right there. So it looks, well, it is on a shelf though, sticking out. So I could be looking at the shadow and the shadow. Yeah, that's my cat, right? I could be looking at the shadow. So after they cut it and transported it, they fucked it up. There's some broken concrete. They impacted pretty good. Remember, they're transporting your stuff on trucks over highways, vibrating. There's no ice damper. It's not put on rubber or isolation dampeners or anything like that when they transport it. It's just toss it on the truck, take it over that warehouse, move that shit out there, move it over here in the sun, and then you complain about possibly the steel swelling. You exposed it yourself for 3 years, and then now you're going to bitch about it. All right, I don't see, this is very interesting. The steel, I'm looking for the cuts in the steel. There's a couple of shiny spots right there, but remember, they left this out now, so I can't tell. Maybe that's all been cut here. But maybe it looks like I'm seeing deformation here. I mean, the guy cut right where the steel was. Maybe it's flat right here if I look at it. See that section right in the middle? So this looks a lot more flat. So if I were to get deep, if I could have a better image, this probably would all show flat here where the saw cut it. Okay. Then he tried to move over a bit to stop cutting it. Let's see if he ever gets over. Not until here, where he gets over and clears the steel out here. So right about here is where he starts moving over. So it tells you about the location, locating the steel and moving away from it. Well, what else this tells you is that here's the steel, and there's the top steel. It would be nice if they measured that, because then we would determine the spacing. All they do, give us this measurement. These are the ones we want. You see that the spacing is different here. There's some 2 here. This spacing is greater than this spacing. Okay, so this spacing now is greater. It's the bottom steel. It's greater than here. So they've got some staggering. So maybe the next steel, this would be here, maybe behind there. Let's see if we can find another piece. He's right on it, but yet I can't find that steel. I can't find that steel. I can find the bottom steel, but the top steel, I find it pretty far apart. This should just be one video, this one. But this, guys, is, let's just say, this is 16 inches, this is 8 inches, this is 20 inches. Just showing you that the placement of the bottom steel is kind of random. And now here we have, another distance. And yet Nist is and I don't see the cross steel, but it's not. It means you might have missed it on the bottom. But what you're observing here is that the spacing is erratic. Now, let's see if we can put it somewhere else where it wouldn't be erratic. Now, it's coming up erratic. Because if this was a column area somewhere here, if this was a column area, that the two of them went across there, across the head, then the, and I'm thinking of the, like, 19.5s and 6.5s, things like that. Well, the spacing gets erratic. The spacing is erratic. It doesn't make it into the critical shear zone properly for that. This spacing is erratic. All right. Looking at the top deck there, I don't know where this came from. I don't think it's a wall. They don't reveal the distance from here to here. That it's, where's it from? Maybe I'll give you one more, but no, it's. I don't know where we're going with this. This is just NIST is saying, look over here, what we found. Remember, they're going to try to save ACI's ass. So ACI is going to try to get saved on this because they're just saying things like, like pointing to this like it's a defect, that 2-inch. If I look at the neutral axis and the steel bouncing around everywhere, depends how it was loaded. It's not this 2 inches. You're looking at something that might be offensive. And we don't know how it was, moved around. These fractures we see, did they create them with their movement? All right? Did they create these with dropping it? Because I see a little fracture here, but that could be a break because the way they transported it and placed it and everything else. You can literally see that here's some... looks like the forklift, tearing off materials. And I saw that when they bragged about moving it from A to B. I saw the forklift tearing up more materials off the samples. So they're getting samples on the next location that have been damaged by the forklift. So, what BS are you what smoke are you gonna blow up somebody's hiney? And any complaints about this additional fill paving things, you need to look at Tong Lee. That's the engineer that put this weight on here. Why is he not being called to impart that class action lawsuit? Why did he get a pass? I don't think his company is out, are they? Or maybe, dead or whatever. I don't know. I didn't research him like that. Now, over here they're showing... really, NIST, Mike Bell's there and all. Bell's there, and he's there, and you expect more. I've seen his classes. I've seen his YouTube classes. I think he's wrong on some of his extrapolations, what he's trying to teach, on a couple of things he has on YouTube. I could talk bad about him, but that's not my intent. It's just saying that they're all just the B team of the A team. All right, they're all just B team here so far. They're pointing at A and then B. B is supposed to be trying to indicate, look, rust. Well, look at the deformation is what matters. The deformation of the steel. Does it still present as like new? Because rust can be present on reinforcement, and it's legit. It can still help if actually increase grip force. It's okay. What this tells you, though, is the paste was here. See the whiteness? The whiteness. The white is there. So that means it had a grip force of paste. And if they zoom macro it, then we'd be able to see a little better about which direction it pulled out. In this case, and we don't know, again, how this was damaged. So what is bent up above the concrete? They transported it and moved it with excavators, and it was not like an archival, real police investigation. This was just throw that shit in the truck, take it over there, throw it on the ground, we'll get to it. And now it's pick it up again, throw it in over there, and we think we know where they go. So, yeah, you're showing me this, and it looks like it's the end. What was it cut? Or did it bend there? Did it bend there, and there's that little tail? That would actually indicate that that's where it bent from to get it to pop off of that piece of wire right there. This was on that wire. See the wire? I'm going to draw it. It was there, holding across that steel. Okay, so here's another sample I zoomed in. So again, what's the purpose of them outlining these cracks? You don't know the source of the cracks. All right, that's a bullseye that they use for 3D or whatever. We don't know the source of the cracks. So what's the purpose? You don't know the source of the cracks of either collapse of the building because they did not investigate this at that location. What would matter is, again, looking at the reinforcement. And we zoom in, and that looks tight. If that's the steel, that looks tight around it. It looks tight, and there's some steel here. All right, then you look at the deformation of it. I don't see where they saw cut this. I can't see this, my striations. Let me take a look. Okay, there they are. So striations are here. And he took it out, and then he plunge cut. Then he Then he plunge cut again there, and then plunge cut here, and then plunge cut there a little bit, and then there a little deeper. And looking over here, these were where stones were that popped out. It's not honeycombing, it's where stones were in contact with the reinforcement. Keep in mind that that would be less paste there when the stones are touching your reinforcement. And so here you would indicate probably more exposed, less paste. Because the stones are literally touching that area, it's still got great bond force around it. This crack, unless I see more of the details and you can tell me exactly where this was and why you think that crack means something, it means hey George, it means nothing. All right, it means nothing until, because of the transportation and everything else. You move the evidence. You know what it's like that everybody knows that you can't move the evidence and then put it somewhere else and then say, let's look at it now. As far as that, you first got to document where it was, how it was, everything, including pictures like this. And then once you moved it to the next location, you look at it, photograph it, and go, okay, look, during transportation, this crack developed. It wasn't there before, and we moved it. During transportation, this crack developed. It was not there before we moved it. So we inadvertently caused these cracks through movement. These major chips could be the forklifts. We're definitely seeing powder down here. So it's not powderizing. All right, it's being impacted, rolled, whatever they're doing. Hell, if I know, there could be a pry bar they put under there and try to rotate it over with the forklift, and this is where you get this fracture. All right, let's look at that steel again. It looks tight all the way around it. So this chip doesn't appear to be exactly related to that one. This steel appears to have a curvature to it. As I look at the curvature, I would just think of the curvature. If it's a curvature, we should see a fracture in there like that. Could this be the fracture, maybe like that, right upon that steel? Well, if that's the fracture, I'd also see some on this side. Because not for free, it's going to be compressive over here, over on this side also. And this rotated up with it. Isn't that just tells you that there's great bond strength between this lower section of concrete and the upper, because it presents as no separation between the two. And remember, we're looking at the side of the steel. So at this point, the guy ran his saw right next to it. That's not for free. That saw coming through that blade. Vibration coming through that blade. So with that said, I count all of this, since I can see exactly the steel, not this part, but right about here and more, I count it as corrupted. For example, the building I'm helping out with out there in, wherever the hell it is, Manhattan, Kansas, I'm making sure that it's understood that when you are removing the concrete, that no vibration. So my limits are no movement. Its vibration is very limited in removing the concrete from around the steel, because I'm worried that here's the building top view, and then here's the deck, internal flooring. That the internal flooring has steel in it, and some of that steel's development length is out here. Here's a cantilever here. I'm worried it's out here. If you just go at it like a jackass and just start banging at it, you'll create, and you start jackhammering on top of some of the steel, it could vibrate through the wall and start fracturing the anchor points inside the structure. Definitely out here, but anchor points. So this will be, determined through deflection, monitoring, first that all floors are stable inside, with measurements, really low tech, but measurements, and indicators that can be quickly monitored visually, not having to break out a tape measure again, stuff like that. It will be indicators, sacrificial indicators that would say, oh, we got movement here. And so, in which case, you do propping and you adjust the floor in there. And maybe there's 2 floors in the whole entire building that will have to be done. 2 floors of the internal wall. I did see fractures a couple of them come up to the brick wall. Can't see through the brick wall, but I must do assumption that they're going past the brick wall. Brick wall's veneer, so my assumption to look at it, price of admission, is we remove part of this brick and we literally look to see if the fracture is continuous. Internally, we look also, but out here is for free, removing a couple of bricks and putting them back for pointing. That's for free. So that building is a nightmare. You guys have no idea what it's like working with Kansas architects and engineers, licensed engineers and licensed architects. They are another breed of petty. I mean, it is. I told you I deal with psychology with the construction field. That's mostly with the workers. I've never had to deal with it at this level with engineers and architects. Oh my gosh, it is amazing I don't know, the community out there, a small town, will do. Well, this appears to be the same image from before. There's that wire. Okay, so they state the obvious again. It's a South African term. You're stating the obvious. All right, an old term. But what they do here, remember one time I said to you guys, look at these hooks. That's a hook. Okay, that's a 90. All right, I said, and I corrected it. I said, look, I want you to understand that my brain, just the way it works, that it's, I corrected in the next videos. I wasn't trying to troll you or see if I can pull a Columbo move. No, that was an honest mistake. So I'll tell you when I make an honest mistake based on a Columbo move, I'll say, oh shit. Or I'll correct it in the next video, saying, my brain just froze up. Sometimes I say, I'll point you exactly at this and say, look at that brick. Clearly it's block. I'm not trolling you. I'm not trying to get you to comment by calling it the wrong thing. My brain's on turbo and it just says, this is what I'm giving you for identification right now. All right, so in their case, so this is Nist. They should not be making these mistakes with the multiple level millions of dollars of people looking at this report. this says hooked reinforcement. That is a lie, all right? Since it's NIST reporting this, and this is going to the public, calling this hooked reinforcement is a lie. All right, hooked reinforcement would be like that. This is not hooked reinforcement. This enforcement originally were 90s. Little shear heads. All right, these were 90s. Okay, like that. I then call them rabbit ears because they're folded down like little rabbit ears. Look, see, like little rabbit ears? Folded down. And I tell you, they're indicators and telling us what's going on. Specifically, look at number 28, the scratch marks. I do a video on that. It tells you that part of this going across his head, the deck, this reinforcement went over this direction to your right here, let's say. And this anchorage over here is what became loose. And we know that because if it became loose there, when this goes down, it rotates over. The deck rotates to this side, pulling that long piece of steel with it. Drag, I'm going to remove the stuff, scratching down here and coming to rest. Scratching off the face. They've now dropped the fire hose on it. I guess they thought it would be a good place to put a fire hose. All right, elevate it. So these are not hooks. These are what you see, and this is also indicates where they pull, bent over, that even though they're rusted, they're trying to imply it didn't have any connection. Well, there's paste there. That paste was nice, and even this rust has paste around it down here that it may have held with the deck going down. It could have going north. Let's see, this would be west and east, bending the steel and bending it so much because this was concrete here, right? This column was, and this steel was up here like this. Oops, so let me do that better. There was some integral action like this. I'll just change the color. And this is your concrete deck. Shit. This is your concrete deck. And when it goes down, it spalls the concrete off in the deck. Right there, the little triangle. You'll see, I'll move it in a second. Right where the arrow is. All right, this one up in the air. I think they have another image that I have a better version of that also. Okay, so this is their version of the deck, the planter box, and they just have it dipping down for free. So in other words, this stays where it is, and then here's your dip over here, and they don't show any fracturing upon there. That there would be fracturing there. They show the critical shear zone, stiff as a fuck. It's working. If you think through extrapolation, the bending doesn't start to after the critical. Well, this one starts right about there, but this one has some flexural ability to it. It's not quite 90. It's like, you know, a little bit of bending down. But at the top, they don't show any defect. No opening there. Because they're using these I don't know, this type of drawing where they're now sectioned off where the block drops. Planter box is doing that, falling straight down. But they don't show the rotation, all right? That there's a rotation going on there. They're just showing it dropping down, even though they show that there's tight there and a gap up here. They're leaving out the rotation, all right? That this is no longer square, straight up and down. This is rotating, okay? They don't show the tree roots. That the engineer that was there, the bush roots did this, remember? The bush roots. So where are my bushes? And the roots coming through, causing this as of June 21st. I'm being facetious. And with that said, why don't they say the engineer missed that there's no tree roots here? Because I'm missing the tree roots. So NIST says that they don't call people out, and they don't, part of criminal charges and all that, but this person missed that. With that said, this is the deck plane, the very top right here. See the very top, and they have it dropped down like crazy. Like what? Like almost a full deck dipped right there. Look at that. See that what's left? That little piece up top. They've got it dipping down within. It's not to scale, but we got a planter box to work with. That's the planter box that comes out of the wall like like that. So they've got it damn near dipped fully all the way down. Elevation change from here to here, top of the boxes, are almost an equal 9.5 inches within that short distance. Over here to the right, they have it not that it deflects for free without 11.1, without pulling on the critical shear zone here, because that looks flat right about there. And then here's where they deviate and go below it with the dots. See the down here and up here the dots, as you can see there. So they're doing some what they're getting something for free. Remember I said you get nothing for free. So for free they got the deck sagging there, so it's just stretching without doing any punching there or opening at the top of the head of these little shear heads. Top view, well, top view would be like that. We couldn't see it. We wouldn't be able to see the bends. Yeah, we'd be able to see the bends if we could look at it from the top, figure out the direction, because it would have a corner to it, a 90 turn. So NIST was supposed to expire in 2023. Their money was September, I believe. Now there's NIST, the super scientists of the world, all joined together in one. It's now May 2025. Let's call that June 2025. They had taken 4 years that they state here, just to give you that. They've taken 3 years just to give you this. We're down to, let me scroll through the whole document here. You can pause it. We get this, no explanation. Most people won't be able to interpret it like I just did. So you just look at it and be like, oh, okay. And you get wrong explanations here. You get called hooks. It says pool deck column, post column. Well, we know that, right? Same column on primary evidence facility. Same column? What do they mean by same column? Is it this one and this one and this one is the same? Is this all three the same? Ambiguous, but let's say it's the same column, 1, 2, and 3. Let's take a look at it. Let's see if we can match it up. With that said, I see this. I see this. Okay, so I kind of like it for that. I look to the right. I look to the left, and I say it's 28. Number is only indicated in the right image. Okay, looking at the steel, has it been moved since the firemen put their hoses on it? On that wire, on the rebar down below, I would say no on that one. Now looking at this one as it's laid there, how much during transportation was lost? This is a, what would you say, a 4x4? So this appears to stick out further than 4 inches. So somebody did a little bendy to bend it up. Somebody put a little tooling on there to reposition it to make it work. Whether it be when they loaded it on the truck without cribbing, and that creates a different position of the heads. Again, they left it there 3 years now. So now you're bitching about rust. All right, well, we need to go to this image. And this is not 28, and that's not 28. So, and remember, the excavator grabbed this and ranked at it. Remember, I showed you how they pulled them out with the excavator to grab around it and just rock that son of a bitch until it came free. But what this tells you, this image, I want to give you a clue. I want to give you a clue here. I'm going to stop here at this image. I want you to pause the video for you who want to play around and figure out what you observe. I want you, and I'll Columbo move it because okay, so if you think you can figure out what you observe, just pause it. If you want another hint, come back to the video. And then I'll give you another hint, and then you try again. Okay, the additional hint is, I got 2 of them, but let's see. And I might give away too much. This had concrete on top of it. This is the head. All right, it had concrete on top. What else did it have on top? A critical shear zone reinforcement. Critical shear zone reinforcement that went down here. It looks like the scratch marks. So the break would have been over here, and I might find some rebar standing over here. I cannot with the window there. This might be my scratch mark in that direction. So this might be the rebar inside there where rebar sat at one time. So that over here would be here. Okay, ready? And going to the right. Drum looking down there. I don't see my scratch marks. Remember, this is moved around. It is painted, so this came from the basement. And looking at the rebar, these bends do cause fractures in the reinforcement. That this side gets tight, this gets stretched, and they do fracture a bit in those tight bends. All right, that bending on the steel, the radius matters. How you do that, and it's usually measured like a ball idea, depending on the size of the steel. As I look at the engrossment of it, it's pretty good still, but if this was to keep pulling, there's the fracture line. This piece would come off next. Those cones I talk about. And there it is there, the pressure cones. Internally, it's not doing anything, it's pulling away from it. As I look again at this, I see the paste. I see the the added shaping on the rebar. It looks well there. It looks nice. It didn't erode away. The one down here is a little more, I would say, I can't tell because I can't get closer. I'd say it's significantly more. But I see a lot of paste here and some paste here and some paste on the other side. Looks like it's white. So I don't know how much of this is 3 years of exposure in this warehouse. Okay, have you seen it yet? The clue's over with. There's your rebar times 1. Yeah, it's 1, right? Yeah, that's 1. Yeah, it's that rebar that has that shape like this. Hold on. It's that rebar that's shaped like that. Yeah, that's it. All right. So there's 2 pieces of rebar here. They bypassed right there, snug together, and there's a paste underneath of it, and the rebar went across. All right. Went across there, this shear head times 1 location. I cannot see it over here. It doesn't mean it didn't exist higher up. But at this location, it went left and right. It didn't shear off this piece of concrete on this side or the concrete on this side, meaning going this direction or that direction during failure. That this rebar bypassed each other through failure and went into the plane of its connection of that direction also, and the other part of the deck went the other way to bend over the heads. So you're looking at it, and I would, in both sides, try to hold on for a minute. There were some, this is the column. There was some sagging on both sides of this deck, where this groove was like this, where it went like this. And what it did was it ground off these corners, as you see it in the background here, and maybe here. I say maybe because I don't know how much damage they did during transportation. But it tried to hold on, and it was a lot of stress before it finally broke bond with each other, and they just ripped down and maybe ripped down there. It's a maybe. That's what I see. I would really need to see a little more. We zoom in. We look at it. I'm trying to find the profile inside these ribs inside here, and it looks like that's the rib. That's where the two of them meet and create that little void, that, you know, like this. So that's that little, see the hill? See what's left behind? This part. That part is this part in the middle. I'm going to remove it, and you see it there. That would tell me the sizing of the rebar because I have part of it right there. So I'd be able to tell you what size rebar was inside that hole by the measurements there. I'd be able to tell you how much of it deteriorated, but how much, again, how much was put there and intentionally initially. What it tells you is that you do not, even over these years, whatever this photograph was taken, you do not see rust around here. So that bar was not rusting. Those bars weren't rusting. It didn't create any rust stains. As we look to the left, this bar with the rust on it created no rust stains. So there was no water penetration at that location causing that. I would say no water penetration over all those years. It would have stained that concrete significantly. I would say I'd give it a no, a 0 on that. Part of it during the failure process, you get that, but this looks like that deep impression grinding. Imagine that piece of steel having all that load ability on it. That this looks like part of the grinding and then tapering off to 0. And if I could see the other side, we'd be able to talk about that side of it. Okay. The concrete is whatever it's composed of, it's still tight here. Remember, this has stirrups inside of it. So this has stirrups. Stirrups around here. Around that steel, around this steel here. And it wouldn't be out here, it would be tight to there. So the photograph is a little bit distorting, but it would be tight like that. And so this would be a little bit of cover here, and this presents as more cover here. Presents, remember this tapers away from us, so it just looks that way. Okay. So now I told you about stirrups. Now let's find the stirrup. This appears to be a stirrup track right here. Right there appears to be a stirrup track. Let's see if I can zoom in. And if I could find the track, the groove, remember the concrete groove like this? That would be there. And I know this looks like it's dropping off. It's not. This concrete spall is dropping off. So's that one. And then this one comes around it like that. You could measure and see the quality and fit and finish, how great they were doing this. You could then explore how deep this is, even though I know that it's deep enough that it held on, that it spalled the concrete. That was not the failure of that. More than likely, it's just the punching shear, even though they do all the evaluation with this circle and arrows, it matters per column. So per column, they have access to. Per column, they can say, what do you get by overlapping the steel here, whatever size that is, 1/2 inch. We see that there's only one there. The others are outside or maybe on top of these these guys. So this steel is down here. This groove steel, it's laying down here. It's below. Did they put steel above on top of this? I don't see any indicators like it wore off or anything else. So the bottom steel is down here. I don't see the upper steel on top of that, on top of those. I'm sorry, I should change colors back. This is the lower steel. All right, lower steel. The upper steel doesn't appear to be there. It could be underneath of it. So the red could be underneath of it where I don't see it. Doesn't mean it's not present. But it still goes up outside of this, above this. And I would know how much it goes up above just by extrapolation or bending, after you get all you get from it. Bend it the fuck back. Bend it back. And you just don't bend it back where you cause failure. Maybe heat it up, monitor the temperatures, and bend it back. Just enough to get it back in place. Maybe grab another piece of steel, duplicate it, and butt it against there, and butt it against here, a brand new piece of steel, and try to extrapolate it. That way you don't do any destructive damage to it, as I just said. So over here's that same piece, as they said, same. So there's my tracks times 2, and this is the face, and then there's this piece that's clean broken off. It's smooth. And so was it plastered, the column plastered afterwards? And if it was, they would have to flip it over and look. Did they plaster right up to it? Still doesn't matter. This steel held. Let's get you more. So this one's titled Variable Corrosion of Slab Reinforcement. It might be kind of hard for you initially to see what's going on here, but let's see if I can do that. That's steel, all right? Remember first that you can see the deformation. There's the ribs, all right? You can look at it. They look like they're brand new with some time on them. This, on the other hand, that's steel also. This steel might have been getting moisture on it. That looks like I can't find my deformations. Maybe it was part here, maybe part here. This steel looks like it was corroding. But again, it's 3 years later to presenting a photograph. I don't know how old it is. The corrosion wasn't enough to wipe out that knotted wire tie. That I don't know if this gap was created because of the swelling of the steel or not. I don't know that, or they're still in the collapse and then they now present this to us. I don't know that that's an issue. Looking at the top part of the steel, so looking at the top part, you now see the deformation. So let me draw them in and take them away. Doop, doop, doop. I see them clearly. Now I see them roll over and then back, because this is a round pipe. Roll over, significantly high there. Over here, this is paste, so it's filling in a section, so it's hard to determine. But I would say that direction. This looks like a piece here. Let's move it and let you look at it. So, but I would, it looks like it's significant water there. You see the rusting color variations in the concrete around it as it leaches into it, the concrete, and they stain each other. Okay, so Nist, once again, is lying. They don't have the ability. I can play and troll and have fun. They don't have the ability to lie. I would say, look, original architectural drawings. Oh, nice jacuzzi. Okay, that's my Columbo move. Because in the original architectural drawings, there was no jacuzzi. So that's a lie to say this is the original architectural drawings. It's an original, because he's got multiple versions. But it's not original architectural drawing as in this is drawing number 1. Not true. False. A lie. All right? This was not part. This was later rendering, late May, somewhere around there of 1980 when the pool popped in, I believe it was, and some alterations took place where no longer planter boxes inside here against the wall, but planter boxes are are there. Okay, and then if they're going to talk about original plans, who gives a shit about what they're saying? Look, smoke a magician act, all right? This is a magician act. Look over here. Look over here. Look here. We should be talking about the BMAs that were there that was part of the load elevation deck changes. But in this report, this one here, they don't talk about it because that might point back to the municipality of saying, why did you accept that change, even though they were the special inspector? How come you let them do a deck elevation change and this presents it only as the 11-foot 10 deck and not the shit. This presents it as 11-foot 10 deck and not the elevation change that was supposed to be here with some BMA action going on here. Beam action, I think it's so it came across here and then it cornered here like that. So right about here, where's all that? And that would have been, I think there's a beam that would have been put in over here to support it. Where's all that? Oh no, it's back here. Here we go. So where's all that action? And that would go there and like that. That's what it was. So where's all that talk of that about original intent, original design? Why are they ducking out on that? And yet we get to see circles and arrows. This is just for the ignorant people that will not question. I mean, really, Nist, this is the best you got? Bell is the best you got, and Bell, I'm calling you out on that video. You can call me out and say, show me where I extrapolated wrong. I can show you where you extrapolated wrong in a video to a student. It was a female student. You came over to help her. There's your hint. Don't delete the video. I already have the content recorded. And this is your Glenn Bell. Look, guys, some people are, you're getting a little old in the tooth. Your brain just, is not, we all know your synapses and your ability to think. It's locked in. You got too many biases. You got too much ego, too, also, rather. This is something, this is something that a student would just be guesstimating at. This is shit. All right? This is shit. This is not talking about, they had a chance here to add the original load path. This is nothing. This is something that we see in a photograph that they just now put in a drawing and made their little dots and arrows. All right? The stresses are all 90 degrees to each other. That's bullshit. The stresses are not all 90 degrees to each other. There is a rectangular array issue going on, torque issue going on. That's how we get to this K1 issue. Even the engineer of record that did this, he knew it was offset by 6 foot and some change. So, right there. Sorry, guys. That this is offset by 6 foot and some change. Up, over, diagonal. So, this report, this is a few pages to it, but I wanted to share this one with you. I hope you can enjoy it. Take care. Shout out again to Cheese Blogger for talking about back here with my Columbo hints, even though I gave some large ones. He is the one that came forward and said, "Oh, I get it. It's the axis point, the mid-axis changes per the loading on the structure at these BMAs, high, low, multiple loading. The mid-axis changes everywhere. That's correct. Mid-axis changes on this deck area also because of loading. Mid-axis changes over here also because of loading of the vehicles." How it stresses into there because of loading of the concrete pads. Mid-axis changes, all right? The axis point changes. And if the axis point changes, Your steel needs to compensate for that, so you can change and have reinforcement that will compensate for your mid-axis. Shout out to the engineer that did the core samples. He apparently nailed exactly the location of errors, which would be here and here. As I observed through the live videos that they've now taken down, I looked at the deck as they were cutting in the middle of the night and everything else. That deck was solid as fuck over here. It was not like over here or here where it was fractured and broken and separated. That deck, when they cut it, it was nice looking. I expected to see it to be, those sections of concrete like that. But the engineer knew exactly where to look. And why did he know that? He knew more than what he said in the report. He knew more than what he said in his reports. He could observe it, and possibly it was proprietary. I've given away a lot of proprietary stuff for you guys, and he didn't want to give away that, okay, through my measurements of this and measurements of that, I determined that deflection was mostly over dropping, deflection was mostly over here. So I said, let me get a core sample here, and through my measurements and elevation and this fracture here, I determined that I wanted a core sample here. Now, he didn't nail a couple of the other core samples further out in the building. Those results came back with just smaller dimensional or thickness, if you will, core samples. But dude just slammed these. Just slammed them. Nailed them. All right, again, cheeseburger, yes. The loading changes, all right? Your mid-axis point changes with all this loading, how they tie into the side of the beams and everything else, and how it deteriorates changes the mid-axis point. The fractures changes the mid-axis point of all this area here. Once you see the fractures here, using this only, once you see those fractures, the mid-axis point changes for everything that is engaged with that area, with that, up to that control joint, because that's where it breaks free. So everything is engaged with it, is controlled there. I want you to tell me, cheeseburger, if this control joint we see goes across here, and I use that number 12s coming across. This is going to be another video, but I'm doing it now. Well, it doesn't keep going, does it? It's here. How did they secure it across that joint? How did they secure it across that joint? Any engineers out there? If that's the level of the deck, and this is the continuation all the way down, and you're not allowed to joint over top of a beam, it's stated, or a column. So there's the section they chose. Let's see, it's right about there, yeah. Yeah, right about there. There's a cantilever over top of this one out to here. And it goes all the way back to the building there. Oddly, though, there's a car that doesn't get crushed. It pisses me off that it doesn't get crushed, because I would think that this car is in that damn crush zone. We know that we see it. It tapers off like that. Why did it taper off like that? Well, from here, from a picture from here, you could see where we could see underneath of it that it was in place, because we see this upper deck, like we can see under the upper deck from this point of view. We can see from photographs, so it's still supported there. And it went over, and what did it do? Let me just give you an idea real quickly. It pulled from the connection. Okay, where the hell are you? And it's almost as I'm a double dip here. Remember, the steel only comes over to the joint, and this would be the expansion joint. When it goes down, I got a vehicle here that I can't disturb. I don't have rebar on that vehicle. Not on the front of it anyway. I don't have concrete on top of it. So I'm going to have to, looking at a different angle now, here's the vehicle. I've got to flex my concrete here. I got to leave it up top, all right, and drop down this deck. All right, so now leaving it up top into that joint, I have to have the rebar that's over here that's engaged onto this, up to the joint, because the joint's right here. We're right there. I just need this rebar to come out now. And this deck can stay in a little more cantilever over to my beam a bit. Beams over to the beam a bit. And I got to get this deck dropped on the ground without touching the car. So here's the car. Cannot touch it. I can see it in the images. It's clearly has concrete above it, but it is not touching it. So I've got to leave the concrete up. All right? It just stays up, period. You don't get to take it down. It stays up. No matter how pissed off you are and confused. You can't do that because the deck's got to come down a certain way. The car indicates it was nothing on it. So whatever you do, you have to leave that concrete up there above the car. It's got to stay. It didn't magically fall down in the car and bounce off. Okay, wait. I'm going too much in this video. I got two ways to get there. One, the rebar, these number right here, these number 4s comes across, goes to the joint. There's some overlap from this joint just to there, a little small piece, and it's able to act in cantilever and stay up there. Don't like that one. That one's just stupid. Doesn't work. We got a rebar coming over to our joint. When it goes down, that part of the BMA stays in place for a moment. And now when she goes down, it flexes around the BMA. Okay, so here's the BMA, here's the column. I'm double dipping, so this is the BMA. This is your deck. All right, I'm gonna do, there's your rebar going over to the joint, to this joint. Now I'm going to double dip a bit. I've got this sagging down, this section here. I'm going to sag. This is going to fold over. Fold over and come down. And when she comes down, bam, she still misses the fucking car. All right, no matter what, you got to miss the car. So this is the area that's I'm working on for you. Missing that car. This is so... It's kind of easy to get to, but can you get there? Remember the rebar's there. Can anybody get there with all these clues I just gave them? Can you get there? I've gotten there already. I'm already inside the tower telling you about how the roof collapsed first after the building shaked, and then it went down and then buckled the floors later. That the roof has indicated. Then I'll show you why, and I'll show you how it rotates up there. Not the roof. I think it's the... maybe the second floor below the roof that gave way, that failed first. And that's when we get our rotation, etc. End of this video. I hope you can enjoy it. This is a little bit more in depth than yeah, I'm sorry, I'm making enemies. They're not going to hire me anyway. No consulting for them. Glenn Arbell is the associate lead investigator. My left dick, I got two dicks, identify with two dicks. My left dick does better than Bell does. All right, maybe I'll edit that last part out, but for fun I'll leave it up there for a couple of views and then I'll pull it out. Do not meet original code, DCR 1.0. Okay, let's address that. Does not meet original code. If I told you guys that, you'd want to know. Show it to me in the code book. I told you that it's rectangular array. I showed you in the fucking code book where this section does not meet code. I showed it to you. I showed it to you in the original book that I own, that the rectangular array is there. This just says this hocus pocus crappery, blow me type crap, right? It's just crazy that we know that this is the beginning point per the June 21st video. I have images stating that. I talked about, my timeline talks about rectangular array, this being out of bounds. And this happens to turn out per the June 21st image. There's another image before that, I believe, wait a minute, June 21st. Yeah, there's an image before that shows it's fractured days before. That shows that deflection. So all this is, their end goal is to protect the municipality, and it looks like blaming it on the architect, the dead people, architect and engineer not meeting code. Instead of saying the municipality allowed them to deviate, all for tax dollars. All right, they remember they extorted them for plumbing. They gave them the permit, then they said, oh no, your plumbing is not going to meet our water requirements. You're going to give us, another 200 grand or something to get this, to keep this project going. They extorted them after they got it going. All right, the new plans, they suck. I got a video coming up soon on that. That guy there it's a British and Iraqi combination. It looks like it belongs in the middle of 1950s. Throw that shit in the trash. It looks like I'd tear it down. If I owned it, I'd sell a piece of it real quick. Love you guys. Bye. The rendering looks like shit.